So this is test 3, question 8, and you are given this alkyl chloride, and it undergoes an E2 elimination to give you 2 possible products. And the question in 4B was draw the Newman projection of the conformer leading to the major product. And how would you rotate this model? Once you built a model of this compound, how would you rotate it to get this Newman projection? So here I have the model that I built, and you can see the T-butyl group is right here. You can see that the chlorine group is right here. You can see that the hydrogen that's bonded to that chlorine is right there. And most importantly, you can see that the 2 beta hydrogens that can be eliminated are right here on this carbon. Note that the other beta carbon has no beta hydrogens, so you can't form a double bond between these 2 carbons. So now I'm going to rotate the molecule, or rotate the model, so that this carbon is in front, and this carbon that has the chlorine on it is in back. Okay, so now I have rotated this so that this carbon is in the front, and you can see that right here, and that lines up with this carbon right here. So there is the CH3 group that's right here, and here are the 2 beta hydrogens. The carbon in the back has this chloro group attached to it. It has this hydrogen attached to it. There's the chloro and there's the hydrogen, and also it has this T-butyl group, which you can see right here. This is the conformer that leads to the major product. You can see here that the major product is the one that is trans, or E, and that forms because when you look at this conformer, you can see that the chlorine and the hydrogen that are going to be eliminated are here and here. And recall that this is an E2 reaction, so everything's going to happen in one step. And so when that elimination occurs to form the double bond, the CH3 group and the T-butyl group are going to end up on opposite sides of the double bond, which is what you see right here. This is the major product because we have the large alkyl groups anti to each other, so that means this is the lowest potential energy conformer. That means that the transition state leading to the alkene product looks more like this conformer and will also be lower in potential energy. That means it'll have a lower activation energy, and therefore this compound is going to form at a faster rate, and that's why it's the major product.